So we're talking about rate problems here. Rate problems involve two objects traveling at different rates. So it's important that we understand rates. In this case, we're talking about different speeds, but rate does not always mean speed. They could be going in the same direction or different directions. They could start at different times. You know, that's rate problems ask us these kinds of questions, like how long does it take them to catch up? How long does it take for them to be 12 miles apart? How long does it take them to travel 45 miles, whatever it is? We're going to use pictures and tables to help us answer these questions. So let's take a look at this one. Train A, please. So train A leaves Pittsburgh at 1 p.m. So let's mark that. Train A leaves Pittsburgh at 1 p.m. It is traveling 80 miles per hour. Train B leaves Pittsburgh, traveling the same direction at 2 p.m. It is going 100 miles per hour. How long will it take for Train B to catch up with Train A? There's two ways we can think about this problem. The algebra way is actually quite complicated and confusing, and we will not be doing it. Okay? So we're going to make a chart, and I like to save room, so I make my chart this way. And then I'm going to write numbers 1, 2, 3, 4, 5, 6, 7, because that's what I have room for up on top of my chart. What do these numbers represent?
Hours.
Hours. They do? 1 hour, 2 hours, 3 hours?
Yes.
No. They represent 1 o'clock p.m., 2 o'clock p.m., 3 o'clock p.m., 4 o'clock p.m., 5 o'clock p.m., 6 o'clock p.m., and 7 o'clock p.m. I'm going to go ahead and write that down here because I don't want to write it down every time because it's annoying, but it's not representing hours. Does that make sense? Okay. Train A leaves Pittsburgh at 1 p.m. It's going 80 miles per hour. So at 1 o'clock, how far has Train A gone?
80 miles.
No, nowhere. At 1 o'clock, Train A has gone nowhere. It's just leaving the station. At 2 o'clock p.m., it's gone how far? 80 miles per hour. Because now 1 hour has happened. So if you're going to label this as time of day, you can't do that. What about this one?
160.
160. And this one?
240.
240. And this one?
320.
And this one? 400. And this one?
480.
480. That's how much room I wrote. Let's see if I hope I don't need any more. So what about Train B? It leaves Pittsburgh traveling the same direction at 2 p.m. It's going 100 miles per hour. So at 1 o'clock, how far has Train B gone?
0.
At 2 o'clock, how far has Train B gone? 0. It hasn't left yet. It's 2 o'clock. It hasn't moved yet. It's barely starting. It's going chug, chug, chug. It hasn't started yet. It's just getting started. It's gone nowhere at 1 o'clock, at 2 o'clock. At 3 o'clock, how far has it gone? 100. At 4,
200.
5,
300.
6,
400.
and 7. 500. Now, I didn't need to go to 7 because what do you notice?
They meet at 6.
They meet at 6. Now, here's the hard part of this problem. Is this chart hard? Is it even kind of hard? No, as long as you can count by 80, or really by 8, and put the zeros on the end, right? And count by 100, you're fine, yes? So, here's the hard part. Answering the question. Because there are 3 valid answers. 6 o'clock is a valid answer. 5 is a valid answer, and 4 is a valid answer, depending on the question. Why? What if the question said, what time did Train B catch up to Train A? What is the answer? 6 o'clock, which is why I drew this with this delay in it. And I used hour of the day instead in case the question asked me, what time was it when they met? Because it could, right? It could ask me that. It didn't, but it could. What about Train A? How long was Train A driving? 5 hours. How long was Train B driving? 4 hours. So we need to make sure we understand the question. So we've got to be very careful, otherwise we're going to get the problem wrong. So, how long will it take for Train B to catch up with Train A? 4 hours. Why am I highlighting that? You need to write the sentence. So 4 hours for train B to catch train A. Because again, if you don't understand the question and you do all of the right work and actually do understand the situation completely, perfectly, you could still be wrong. Because the answers 4, 5, and 6 would be on a multiple choice test for sure. So if you're not completely understanding the question, you could get this problem wrong.